Welcome to our third video on linear relations. In this video, we're going to be learning how to graph horizontal and vertical lines, and also what their equations look like. So first, we're going to start off with a quick recap of how to plot points on a Cartesian plane. First thing to remember is the difference between the x-axis and the y-axis. The x-axis is the horizontal line here, and our y-axis is the vertical axis. Now when you're plotting a point always has two values, an x value and a y value, separated with a comma in the middle there. So if we had to plot the point 2, 3, first we would look for an x coordinate of 2 and a y coordinate of 3. So along the x-axis, we always start at the origin that's in the center here, and positive 2 would mean we go 2 to the right, so here, and then a y value of 3 means we go up to 3, and that would be our point there. So it's basically saying when x is equal to 2, y has to be 3. Another quick example, let's say we had to plot the point -4, 0. We would find the x value of -4, so since it's negative, we're heading to the left. 1, 2, 3, 4. And then a y value of 0 would simply mean that we don't move up or down. So that would be that point there. Now, the first equation we're going to look at is the equation x equals 4. We're going to try and figure out what that looks like if it's graphed. So the idea here is we want to plot every single point we can see that has an x coordinate or an x value of 4. So along here we've got our x-axis, along here, and we know that x is equal to 4 right here. So I'm going to draw a dot there. We know for sure that point has an x value of 4, and in fact a y value of 0. If we were to plot that point, it would be 4, 0. But there's a whole bunch of other points that also have an x value of 4. For example, this point here still has an x value 4, it just simply has a different y value. If we were to plot that point, it would be 4, -3. Another example would be way up here. That point, if we were to properly label it, would be 4, 5. So it has an x value 4 and a y value of +5. But again, it still has the only thing it needs to have is an x value of 4. And so it does satisfy this equation. And so you can start to see that every single point along this line will have an x value of 4. The only thing that's different is that the y value is changing. But that's okay, because the equation is simply x equals 4. And every single point along here does have an x value of 4. So we should actually connect them with a line if we're plotting it properly, and also add arrows on both ends. And the reason we do that is to imply that it actually would go on forever, till infinity, in both directions. So you can see from this example that the equation x equals 4 becomes a vertical line when it's graphed. And that'll be the case no matter what. If x was equal to 7, 100, a billion, it would always create a vertical line. Now let's take a look at what happens when it's y equals a number value. So let's say we had to graph the equation y equals -1. Well, so now we need to try to look and plot at all the points we can think of that have a y value of -1. So along our y-axis, we know we've got a value of -1 right here. I know that looks like a 1, but it's actually negative. Okay, and then this point here would also have a y value of -1, just an x value of 3. So that point there, if we were to plot it, it would be 3, -1. This one here, this point here, all of these points have the same y value, which is -1, and it's just the x value that's being changed. So again, we're going to connect our dots, add the arrows. And so you can see that when the equation is y equals a number, we create a horizontal line. So now when you're given an equation that needs to be graphed, you can tell pretty quickly whether it's going to make a horizontal line, a vertical line, or a diagonal line, which we call oblique. So, horizontal line, which would be like the horizon, flat, that happens when we have an equation with only an x value. Or, sorry, y value. For example, that last equation we did, or y equals -1. We would get a vertical line to form if our equation only involves an x value. Like in that first example, where x was equal to 4. And then finally, the third type of line we can see is oblique, which means diagonal. And the equation in that instance would include both an x and a y value. Actually, I guess I should clarify, not only values doesn't seem like the right word. I would say it includes x and y variables. I think that makes more sense. So an example of that would be if we had the equation y equals x plus 2. Because in this equation, we've got both a y variable and an x variable. So let's do a couple quick examples, and then we'll be done for the video. All right, so let's say we had to plot the equation x equals -3. Okay, so I like to start by looking at our x-axis and finding where is x equal to -3. And so our x-axis along the horizontal here, and it's equal to -3 here. And I know that x could also be equal to -3 anywhere along this vertical line. So our equation, or sorry, our graph is going to be this vertical line that goes through the x-axis at -3. That's as simple as that. Okay, let's try another one. Sometimes you'll be given the graph itself, and you'll need to label it or find the equation. So it's kind of like the opposite of what we just did. So maybe you would be given this graph, and we need to find the equation. So I'll think all of these points along this line have something in common. They all have the same y value, this y value right here, which is 4. I mean, if we were to plot these points, this would be 1, 4, this one would be 2, 4, 3, 4, and so on. So you can see every single time that we have a y value of 4. So the equation for this would be simply y equals 4. Let's do one more. How about this equation here? Or sorry, this graph. Okay, so let's think. All of these points along this line have something in common. They all have the same x value right here. X is equal to -2. So that's the equation, because they all have the same x value. Alright, that's it for this video. Hope it helps.